Hello and welcome. In this lecture I want to talk about converting strings, some more string functions. It's very common to convert character case specifically if you want to make your string all lower or all uppercase characters. Luckily there's a toUpper function that converts from lowercase to uppercase and a toLower function that converts from uppercase to lowercase. So lowercase to upper, upper to lower. Both functions return either the converted character or the same character for characters that are already in the correct case, or are not convertible, such as punctuation characters, if you can't convert them. So this is how you can convert a string to uppercase. Remember, these are actually utilized on character by character basis. So if you had a buffer that was a character array, you would have to go through each element in the buffer and then do a toUpper on that character. So here we're going through each element in our buffer character array and we're passing it to the toUpper method. And that's going to return a character that's in uppercase and we're going to assign it to our buff sub I. We're going to do that until we hit the null character. So this is a for statement that just has one line. This converts the entire string in a buffer array to uppercase by stepping through the string one character at a time. The loop stops when it reaches the string termination character, \0. The cast to the type char is there because toUpper returns of type int, which is the ASCII value, and it just converts it. And you would do the same thing if you wanted to convert it to lowercase. Very simple to use the case conversion functions. All right, so you can use the function toUpper in combination with the stir function to find out whether one string occurs in another, ignoring the case. So let's look at this example that does exactly that. Here we have two character arrays, text and substring. Text is 100, size 100, substring is size 40. We ask the user to enter a string to be searched, less than 100 characters. We get that, we store it in text, and then we enter the string that they want to find using the stir, so then the substring. So they enter some other substring. We then print the first string and then we print the second string. We then convert both the strings to uppercase. And then we can actually say the second string found the first string. So when we call stir, it can ignore case, because remember, one of the limitations of stir was that it was case sensitive. And so now we can use stir on text and substring because they're all uppercase characters. And again, this is a way to find whether a substring is an entire string, ignoring case. First, we just convert everything to uppercase, and now we're comparing uppercase. And that's what this program does. It's often the case that you'll want to convert strings to numbers. So there's specific functions that start with an A. They're like A2F, A2I, A2L, and A2LL. It's not ATOF, A2F. A2I is very common, converting a string to an int. So A2F is going to convert a string, and it's like ASCII to F. It's going to convert a string to a data type. So an A2F is an ASCII to a float, or double to a float. And you may have certain return values if it's not found or can't do. So sometimes you can't convert strings to integers, especially if you have a string that just had words, right? Usually you use this function when you have, in the example, if you have a character string that has 98.4, that can be represented as a double. So you can do an A2F on it. If you have a character string of JSON, you can't convert that to a float or an integer. So nothing's going to happen. So when you have character strings that have numbers, you can convert them using these ASCII2 functions. And this is all included in the standard lib header file. You'll also see the opposite. For creating integers to strings, you'll see things like I2A, which is int to ASCII. Though if you had a number, 98, and you want to convert it to a string, you'd say I2A. Right? There's also some newer functions, I think, that do some more. These ones are specifically for string to double as opposed to A to F. You can use these stir to Ds, or store to F, or string to LD. And they each just convert to either long doubles, floats, or floats doubles. But either one of them is fine. The ASCII ones are the traditional ones. I think the other stir to Ds and stir to Fs were added in later standards of C. So here's an example of doing some conversions. It's very, very basic. Here we have a stir character array, 3.5 space 2.5 space 1.26. We have a couple pointers, and we're going through until we jump out as if we can't convert it. So we say stir to D. We pass in our address of our PTR, our pointer, and we pass in our P string, which is our string, 3.5 to 2.5. Now you may say, why are you passing in the P stir as opposed to just the stir? And you don't have to. But here we want to actually check if there was no conversion. So because we're checking for no conversion, we have to look at both pointers. You can't compare the PTR to the stir because the stir is an array. So we're going to use P stir to just represent our character array so we can compare. And if we compare those two, it means P stir stored no conversion. And so we're done. We weren't able to actually convert that value. Otherwise, if we were able to convert the value, we're just going to print it out. And we're then going to go for the next conversion. P stir is going to equal to pointer. So you can run this and you can see that it's going to end up converting everything in the string array to specific values, doubles, double values. I usually use A to I, A to F, but either one of these will work. These are the conversion functions. Thank you.